Hello and welcome to this video on standard deviation. So we've been looking at ways of analysing data, representing data and how to get useful things from it. And the last one we're going to look at is this thing called standard deviation. Now, standard deviation measures how spread out the data is, how consistent it is with each other. So it's kind of like when we talk about the range or we do the box plots and things, but it's a little more accurate. But that does mean it's a bit more annoying to work out and has a, frankly, awful looking formula to go with it. But the actual maths involved with the formula isn't that bad, okay? And you are given the formula, okay? But we do need to know how to use it and what everything in it means, okay? So instead of writing standard deviation, I'm just going to write SD because I'm being lazy, and that's how it's given in the formula. So your formula for standard deviation is a big square root, okay? So that means we're doing the square root of everything inside here. Then we have this symbol, and x minus x with a little bar on top of it, in brackets, and that's all squared, and then we divide that all by n take away 1, okay? This looks horrible, but it's really not, okay? We'll go through what all the things in it mean, okay? We should already know that this means a square root, okay? So if we're using a calculator, we've got a button for that. On my calculator is this button here. Looks like that symbol with a little box inside it. Let's go through what everything else means. Okay, so first, this symbol here, that means the sum, okay? So that means the total, or they're all added up. So that means I'm working out this and then adding them all up. What I use is my x, that's each value, okay? So obviously we need a range of values to be working this out for, and x means one of those values. Make a little bit more sense when we see an example of it. X bar, which is we call x with a line on top of it, that means the mean. Okay, so that's the mean of the values. And squared, obviously we know that means times by itself. Again, we could do that on the calculator. We've got a little button that is x. We press that and that will square things for us. And then n, yeah, that's our number of values. Okay, so n is going to be really big if we are looking at a lot of information. It's going to be really small if we're not looking at very much. Okay, and when we work all this out, that tells us a standard deviation. If we get a really low standard deviation, that tells us something about the data, and if we get a really big standard deviation, that tells us something else as well. So the smaller the standard deviation is, that means the values are all closer to each other and quite consistent. A big standard deviation means they're all spread out and quite inconsistent with each other. Right. Let's look at an example set of data then, and also how you go through this. It's a fairly long process, okay? So you will need to remember the process involved is guaranteed to be asked about. So let's say we've got this set of data, okay? So I'll just put a little line under here to keep this separate. And so we want to work out a standard deviation of a set of data that is 44, 49, 50, 52, and 55. Okay, so I want to work out the standard deviation of this. Now this set of data could be anything. It could be the prices of something, it could be the age of people. It doesn't really matter for us working it out. Okay, so the very first thing we want to do, our first step, is to work out the mean, okay? Because we'll need this. So we're going to work out the mean. Oh, sorry, I'll just move this over a little bit. Now remember, the mean in this formula is this x with the line on top of it. Okay, so from now on, let's start using that letter for it. Hopefully we remember how to work out the mean. To work out the mean, we add up all these numbers and then we divide by how many there are. So we're going to do 44 plus 49 plus 50 plus 52 plus 55. And we've got 1, 2, 3, 4, 5 values. So we divide it by 5. Remember, you will have your calculator for this, so we don't need to worry about trying this in our heads. If we add all these up and divide by 5, that gives us a mean of 50. Okay, so now we know what our x bar value is. That's 50. Okay. Now, the next step is to make yourselves a table, and this will make doing the rest of these bits much easier if we have a table. Okay, so the first thing we do, and we'll make this table, and it's going to have x in it, and then the next bit of your table is going to be x take away the mean. Okay, and then the last bit in your table is going to be the x take away the mean squared. Okay, and now you'll realise that's up here in this formula. Okay, so once we know these, we can start putting things into the formula to work it out. It might not be making any sense yet, but don't worry, we'll do another example after this. Okay, so first thing of the table is our values. Remember, x was each value, so we'll write those down. So we've got 44, 49, 50, 52, and 55. Our next column is x take away the mean. So we're going to do 44 take away 50, because that was our mean. So that's going to be minus 6. So we've got 49 take away 50 is minus 1. 50 take away 50 is 0. 52 take away 50 is 2. And 55 take away 50 is 5. Then our final column on this table is we work out what each of these is squared, okay? Because it's telling us to work out this whole bit squared. So that's it. So minus 6 squared, you can do this on your calculator if you want. That means minus 6 times minus 6, which is 36. Minus 1 squared is 1. 0 squared is 0. 2 squared is 4. And 5 squared is 25. Okay, so there's one last bit we want to add to this table, okay, and that's a little bit at the bottom here. So I've made that table a little too long, okay, and we want to work out the total, because remember, this symbol here, that means the sum or the total of all of these. So we've worked out each individual one of these, and then we want to work out the total of them. So again, we can use our calculator. We want to add all of these up, and our total there is 66. Now, we're getting close to the answer now. We've got all the information we need to put into this formula. So let's write down this formula again. Make sure it's on the camera. Just move it up a little bit. So, our formula, standard deviation, equals x minus the mean all squared divided by n minus 1. So, let's start filling it in. This top line, that was a total of the values take away the means squared, which is exactly what this number is here. Okay, so that means 66 goes up here on the top line. Now this bottom line, okay, that's n take away 1. Now remember, n, that's our number of values. So how many values did we have? We had 1, 2, 3, 4, 5. that's going to be 5 take away 1, which is 4. Okay. Again, we can do this on our calculator. So standard deviation is going to be the square root 66 divided by 4, which is 16.5. Now you will normally end up with a decimal here, but don't worry about that. Oh, sorry. To move that up. 16.5. Last step, do this on your calculator. So if you can't remember how to do this on your calculator, you're just going to press this square root button here. Then you're going to type in 16.5, press equals. It might show you it like this. If it does, you can press this button here, SD, and that changes it into a number we know how to deal with, and that gives us 4.06. Okay? So let's do it to 2 decimal places, which would be 4.06. And that is our standard deviation. Okay? So basically what we're saying is each number there is about 4.06 away from the mean value. Okay? It's quite a low standard deviation, so it means they're not spread out very much, which we can see by looking at it. Okay? When we get to some questions that actually have a bit more context, you need units for your standard deviation, okay? So if we were doing a question where these numbers up here were the prices of something, say that was in pounds, then our standard deviation would be 4.06 pounds. If these were the ages of someone in years, our standard deviation would be 4.06 years, okay? Right, let's look at another example of this, just so you can see another one done through properly before you go away and try some by yourself. Okay, so here I've set up another example. I've written down the formula again so we don't forget it. You will be given this, so you don't need to memorise it. You just need to know what it actually means and what it's telling you to do. And here we've got some data and we've got a bit of context to it this time, okay? So what we've done here is we've measured the maximum daily temperature over the course of a week, and these were the highest temperatures each day. But we're going to follow the exact same steps. Okay? So our first step was to work out the mean. Okay, so we're going to do that, but remember that uses this symbol. So our mean is going to be 7 plus 9 plus 12 plus 10 plus 14 plus 12 and plus 6. And we're going to divide that by 7 because that's how many of them there are. And when we do that, we add those all up on our calculator, divide it by 7. That gives us that the mean temperature is 10 degrees. Okay, we'll put degrees Celsius. That's what we mean. Okay, so we've worked out our mean, which means we've worked out this X bar number. Okay, sorry, you'll see when I was putting the paper out, I put a big scribble on it, but hopefully it won't get in the way. Next thing, we'll make our table. Okay, so we'll have our values with X. We'll have those values take away the mean, and then we'll have the square of that second column. Okay, so our X values, they are 7, 9, 12, 10, 14, 12 and 6. Now, you don't need to write these in order because they're all getting added up, so it doesn't matter what order they are, sorry. Try to draw that straight, I've done a terrible job of it. So, in this column, we're going to have this value take away our mean, which we've worked out here is 10, okay? So, 7 take away 10 is negative 3, 9 take away 10 is negative 1, 12 take away 10 is 2, 10 take away 10 is 0, 14 take away 10 is 4, 12 take away 10 is 2, and 6 take away 10 is negative 4. So, again, use your calculator if you want. For this final column, we're going to square each of these numbers. Okay, so negative 3 times negative 3, that is 9. Negative 1 squared is 1. 2 squared is 4. 0 squared is 0, 4 squared is 16, 2 squared is 4, and negative 4 squared is 16. Now, a little check to make sure you're on the right path. This last column of your table here, this x minus the mean squared, these should all be positive, okay? If any of these numbers are negative, you've made a mistake, okay? These all need to be positive, because a positive times a positive will give you a positive, and a negative times a negative will also give you a positive, okay? So these should all be positive numbers. Right, again, on your calculator or on your head, add those up, and that will give you a total of 50 for those. And now, just like before, we've got pretty much all the information we need now to put into this formula up here and work out the standard deviation. So let's do just that then. So our standard deviation, I'm getting very sick of writing this equation out, so I'm guessing you guys are as well. Apologies. X minus x bar all squared. So that top line means the total of these. Okay, we'll divide that by n minus 1. So we already know the total of these. That's what we use the table to work out. The total of those is 50. Then here, our n, well, that was 7 because it was a daily temperature each day of the week. So there were 7 values, 1, 2, 3, 4, 5, 6, 7. So 7 take away 1 is 6. So now we're looking to work out the square root of 50 divided by 6. Use your calculator again for this. That gives you the square root of 8.33. Last step then, pop this in your calculator now, and if we'll do this to 2 decimal places again, that gives you 2.89. But remember, this had units, okay? So your standard deviation also needs to have units. So your standard deviation is 2.89 degrees Celsius. So what you're saying is, on average, this information, all this data is about 2.89 degrees away from like the average, okay? That's quite a low standard deviation again, so it means there's not really very much spread, okay? If we've got a standard deviation of 8 or 9 degrees, well, that's telling us all these numbers here would be spread really far apart, okay? Hopefully, going through those 2 examples makes it clear the steps you have to follow. I'm going to set you some questions to do. You can leave this video up while you do them, stop it, pause it, wherever you want, okay? Keep it up like this on the screen so you can see the working, whatever's best for you, okay? Right, thanks and bye.